Hey everybody, today we're going to look at the very basics of Docker, why we need Docker, how it works, what Docker really is, and also look at an example of how we can use Docker in our development. First, let's look at why we need Docker. Now, I've been working on a project that has the web server is Nginx, it has PHP and MySQL database server, and it's running on the Ubuntu operating system on the server. I have a Mac operating system. Though I got Nginx, PHP, and MySQL to work on the Mac operating system, there were a lot of compatibility issues. I did have to make certain changes, download certain versions of softwares or dependencies and libraries in order to make it work just the way it is working on the live server. Now, sometimes these applications, even if I have the same operating system, may not work the same way. Different versions of the operating system might have different impact on the software or the application that you're trying to run. Now, let's assume we had the exact same operating system on my local machine and on the server, and the exact same version. We still have issues because of the various dependent libraries, softwares, configurations that both our applications would require. Because different apps, different services would require different versions of existing libraries and dependencies on a machine. So one app might require a version X of a certain dependency, while another app might require a different dependency. Now, this causes a lot of compatibility issues. With Docker, we can eliminate this issue of compatibility. That is because Docker uses the concept of containerization. Now, what is containerization? Containerization is where we can package different applications along with their dependent libraries and configurations into small packages called containers. As you can see in this representation, each application, like the Nginx, the PHP, and the MySQL, are packaged into individual containers, and each of them have their own libraries and configurations. So if Nginx would require a certain version of an application or a certain version of dependencies, and PHP would require a different version of the dependency, it would have no compatibility issue. Now, as you can see here, we have a server, the operating system, and another layer, which is the Docker software. And using Docker, we can have these containers with different applications running. And if I want the exact same setup on another machine, all I need to do is install Docker, and I'll be able to migrate or ship the entire Docker containers to the new machine, irrespective of the underlying operating system. Now, this is because Docker works directly with the operating system kernel. Now, what is the OS kernel? Now, every operating system has an underlying layer which is called the operating system kernel, which is basically responsible in communicating with the software and the hardware. Now, Ubuntu and Mac operating system has the same underlying kernel, which is the Linux kernel. So no matter what operating system we have, be it Ubuntu or the OS X or Red Hat or CentOS, Docker would work exactly the same on all of them. And if we have Docker installed on our machine, no matter what the operating system is, we could have the applications running the exact same way on all the machines. Now, the only operating system that does not share the same kernel as these operating systems is the Windows. And for Windows, we would need to have a different Docker engine altogether. Now, you might ask me what is the difference between Docker and a virtual machine. Now, let's look at the representation here. On the left, we have a virtual machine. On the right, we have the Docker setup. On the left, we got our system with the operating system and hypervisor, where hypervisor is just a software that is used to run and create virtual machines like VMware Fusion, VMware Workstation, and Oracle VirtualBox. And on top of that, we have a virtual machine. Now, each and every virtual machine will have its own operating system, its own dependencies, configurations, and various other softwares, and the applications that we need to run in it. Compared to the Docker, we do not have an additional operating system running on top of Docker. Instead, each container on the Docker uses the kernel inside the existing operating system. Now, because the virtual machine has to have an operating system in it, which is on top of an existing operating system, it's quite an overhead. It requires more resources, more memory, and its file sizes are usually in gigabytes. Whereas the Docker has different applications running using the same operating system kernel, and it does not need an additional operating system. Now let's summarize what Docker is and some of its uses. The Docker uses containerization, which means we can package different applications along with its libraries, dependencies into separate containers. This means that as long as you have Docker installed, these apps and softwares that are bundled into these containers can be shipped onto other systems and it will work the exact same. Docker containers are created using Docker images. Now, Docker images are templates or blueprints of commands and instructions that tell what a container has to do. And containers are basically running instances of these images. Various Docker images are already available online on a repository called the Docker Hub. You can access Docker Hub and you find various official images like Nginx, PHP, Redis, MySQL, and various other images. We can even create our own images with our own instructions and commands, and we can pass these images to different developers or run these images on different machines. And these images that we create can also be pushed to the repository so that the public can use it. Docker containers are loosely coupled, which means these containers are highly self-sufficient and encapsulated. And we can make a lot of changes to these containers. We can update them, we could turn them off, turn them on, and it would not affect the other containers. Using Docker, we can build, run, and ship these containers onto any machine, and it would work the exact same as long as they have the same underlying operating system kernel. Docker is also extremely lightweight as they leverage and share the host kernel, making them much more efficient in terms of system resources as compared to virtual machines. Compared to virtual machines, containers usually require lesser hardware and lesser resources to run, and their sizes are usually in megabits. Using Docker, we can build and ship different environments onto different systems like staging, production, and the local machine, and it will work exactly the same. Now let us look at some basic commands in Docker and how we can use Docker. Now we need to have Docker installed. Now I'm not going to show us how to install Docker. I'll leave a link in the description for the Docker installation. Now if we have Docker installed, let's open terminal. And here let's type docker-v and you can see we have Docker installed. Now one of the most common commands that we use is the docker run command. Now the docker run command like this. Now the docker run command, as you can see here with the docker run nginx, basically creates a container of nginx. Now it will look for an image within the system, and if it cannot find an image, it will download the image from the Docker repository, which is Docker Hub, and create the container. So let me go ahead and run this command. Now to see if the Docker container is created, I'll open another terminal. And here, let us use another commonly used command, which is the docker ps. The docker ps command is another command that is used to display all the containers that are currently running in the system. Now, as I said, the docker run command downloads the image if it does not exist and then creates a container. The Docker container is basically a running instance of an image. So let us see what the images are. Now to view the Docker images, we need to type in Docker images. And as you can see here, though we did not download an image, you can see there is an image downloaded called the Nginx, and it has the latest stack. Though we did not have any images downloaded, when we ran docker run, it looked for the image Nginx, and if it didn't find it, it would have looked through the Docker repository, and then it would have downloaded it. Now let's take a look at the Docker repository. Now this is the Docker Hub. This is the repository of many Docker images. As you can see here, we have Nginx, and if you click on it, now this is the Docker Nginx image. This is an official image by the Nginx team. Similarly, in the Docker Hub, you'll find various official images. As you can see here, MongoDB, Redis. You'll also find images which are pushed by developers. And you'll also find images which are custom, which have various other images inside of it. So every Docker image can include other Docker images as well. Now let us go back to the terminal. Now let's say you want to stop the running container. We can use the docker stop command, which is docker stop, and we can use the container ID and stop the container. Now when you see the container ID being printed again, you know that the command was successful. Now this time if we type in docker ps, you'll see that there are no containers running. However, if you do docker images, you see that the image exists, which means when we run the docker run command, it will check if the image exists. If it doesn't, it will download it. Every other time you run the docker run command, it will not download an image since it already exists. It will just create a container out of it. Now let us run the docker run command again. Let me open a new terminal and docker ps. There you go. We have the Nginx container running again. Now, similarly, we can run multiple containers. Now, if you want to just pull an image and not run it, we can use the docker pull command. And if you want to create an image and push it to the repository, we can use the docker push command. Now, when we stop a container, it doesn't delete it altogether. So if we do docker stop, and if we give the container ID, though the container stops to work, it doesn't delete the container. And I can show you this by going to docker ps-a. Now this lists all the containers, including the containers that are stopped. Now if you want to permanently remove a container, we can use the docker rm command, which is docker rm, and you can give the container ID. And this time, if I print all the containers, including the ones that are exited, you'll see that only one container is remaining. Similarly, we can also delete images if we don't need them anymore. And for this, we can use the docker rmi command. So let's list all the images. Again, if we use -a, we will list every image, and we need to use the docker rmi command and give the name of the image. I got an error here because you can see that there was another container. Though it's exited, there is still another container that is built out of the same image. So let us delete that container as well. And now let's try to remove the image. There you go. If I list all the images, you will find that there are no more images available. Now, I did mention that we can create our own images and run containers out of them. Now, for us to do that, we need to have a template, or what we call a Dockerfile. So in our app directory, we have to create a file called Dockerfile. And right now I just have one command which says from Nginx. Here, all I'm basically doing is I'm downloading an official Nginx image and creating an image of my own. Now, in addition to this, I can have various other commands, but for now, I'm just going to use this one command. Now, to create an image, let us first go to the directory of the Dockerfile. And here we can run the docker build command. Now, before I run the command, now let me explain what the tag does. Now, every image has a tag. Now, if you don't mention a tag, it defaults to the latest tag. This means an image can have various versions, or it could be of different architecture. So every time we create an image, we can tell which version of that image it is. Here, I'm creating an image called test app, and it has the version 1.0. And the dot represents the directory where the Docker file exists. If I was one directory behind, I would have to mention the relative path of where the Docker file exists. And when I hit enter, you'll notice that it's running all the commands. Since I have only one command available in my Docker file, it's running that one command as step one of one, which is downloading the Nginx image from the repository. Now, once the build is complete, let's go ahead and look at the images. There we go. We see the new image called the test app. Now let us run a container out of the new image that we just created, which is the test app. So we'll use the docker run command. Here -p represents the port, and we're telling the container to communicate at port 80 with Nginx 80. And we have to mention the image and the tag. Let us open a new window. And here, if I hit docker ps, you see that we have a container running. Let me open Chrome and go to localhost. There we go. We have Nginx running. Now, once we have the container running, we can access the container using the command docker exec. IT is interactive, and use the container ID. And we're inside the container. We can see what the Nginx version is. There we go. Now we did see how to create an image, run containers, and various other commands. But if we have a complex application where we have Nginx, PHP, Redis, MySQL, and various other services, using the commands like docker run and docker build might be a little difficult. Now in this case, we can use something called the Docker Compose. Now Docker Compose is a tool within Docker, and what it does is it allows us to create a script in the YAML format, and it allows us to build and run images, and all of this can be done by just using one or two commands. Now let us take a look at how this is done. Recently, I've been doing some benchmarking, and I set up a basic PHP application with Laravel code. Instead of me running an Nginx container separately and a PHP container separately, I use Docker Compose. Now, if you look here, I have a directory called images, and I have two subdirectories, one for PHP and another for Nginx. Now, each of these have a Docker file. Now, if this is the PHP Docker file, and if you remember from the previous example, we just had one command, but here you can see that I have a from command, which will download the PHP image, and I'm running some basic instructions, some basic commands to download some of the dependencies that this PHP container would require. You can see that Laravel requires mcrypt, so I'm downloading and installing that. It also requires PDO and some basic commands like running PHP command and what port to expose. Similarly, if I go to the Nginx subdirectory, you'll find a Docker file with some commands describing what this image would do, which is to download the Nginx from the repository, run the Nginx command, and expose some ports. Now I have both of these Docker files in their own subdirectories and inside the images folder. And I also have some basic configurations for both PHP and Nginx, and they're in their own subdirectory inside the config folder. And I have the Docker Compose YAML file. Now let me open this. Now here you can see that I have services. One is the Nginx and the other is the PHP FPM. I'm not going to get into the details of it, but you can see that I've defined a working directory. I'm giving a context, which basically says where to look for the Docker file. I also have these volumes, which creates the mounts, telling to copy the code from my code directory and place it inside the working directory, and also to copy some of the config files and place them inside the container where they have to be. And lastly, I have a directory where I have the entire Laravel code. Now, once I have all the necessary Docker images, their configurations, a script, which is the Docker YAML, and of course the code, I can go ahead and run the Docker Compose command. Now to do this, I need to navigate to where the Docker Compose file is, which is and as you can see here, we have the Docker Compose file. And here we need to run two commands. One is the Docker Compose build. And as you can see, the moment I do this, it's running the first service, which was the PHP FPM service. And if you remember from the Dockerfile, we were downloading the PHP from the repository. And once the download is complete, it would run some of the other commands, like the one we saw where we were installing the mcrypt, PDO, and various other dependencies. And now it's moved on to the next service, which is the Nginx service. And finally, the build is complete. Now, once the build is complete, all we need to do is run docker compose up. And with this, you can see that both the services, which is the FPM, PHP FPM, and the Nginx, are now running. Now we can validate that. Let's open a new terminals window. And if I hit docker ps, you can see that there are now two containers available. And if I go to benchapp.com, we'll see the index page of the Laravel application. Similarly, I can bring up any other service I want. I can bring up a MySQL service. Let me open the terminal. And let me navigate to where I have the MySQL 5.7 service available. So it's just document, docker MySQL 5. And if you see here, I have again a database directory which has a Dockerfile with the instructions and my Docker Compose file. And again, if I do Docker Compose build, again, it will run whatever is mentioned in the Dockerfile, where it's downloading the MySQL version 5.7.29. And it's going to run all the other commands mentioned in the Dockerfile. And once the Docker build is complete, all we got to do is Docker Compose up, and the new database service will be up and running. Again, to validate this, we can just run docker ps, and now you can see a new service is running. Now, switching between services is simple as turning it off and turning on another service. I can just navigate to the database service and exit that. I can navigate to another directory where I have MySQL 8 installed. And again, if you see, I have some Docker files inside the database directory and the Docker Compose file. I can run Docker Compose build. This time you can see it's downloading a different version of MySQL, which is MySQL 8.0. And once the build is complete, we'll run docker compose up. And the new database service, which is the MySQL 8.0, is up and running. Again, we can validate that by just hitting docker ps. This time you see that the service that is running is Docker MySQL 8. This way, using Docker Compose, we can bring up Docker containers easily, and we can switch between any service we want without interfering with the other running containers. Well, with this, we have a very basic understanding of what Docker is, why we really need it. We took a look at what is the difference between Docker and how VMware works, and also how we can use some of the very basic Docker commands, and also had a look at Docker Compose. If you liked the video, please go ahead and hit the like button and subscribe to my channel. Thank you for watching.